Hello, I'm Courtney Carr, Director of Marketing and Education for IAPD. Thank you for joining today's e-training webinar, Cutting Edge ASTM Testing Made Affordable, presented by Alan Goodnight of Wichita State University. During the presentation, you may submit questions into the Questions tab on your webinar toolbar, and we will answer them at the conclusion of the presentation. Following the webinar, you will receive a link to a survey. Once you have completed the survey, there will be a link to download the presentation slides. A recording of today's webinar will also be available for download on the IAPD website. Alan Goodnight is the director at Wichita State University and a leader of the Plastics Industry Initiative. I would now like to turn the presentation over to Alan.
Good morning, and thank you, Courtney. Hope everyone's Friday morning's off to a great start, and we're happy to be talking with you from Wichita, Kansas. I also have with me Shin Ma, who is a research scientist, leader in our ASTM and testing laboratories. So he'll be helping me answer any technical questions that the audience may have. So to start, as you can see, the subject today is testing, research, and training for IAPD members. We've launched a new initiative into the plastics industry, and it's built upon decades of success, primarily in the aerospace and aviation sectors. As this slide illustrates or details, we've been at it for over 25 years, delivering highly complex testing, training, and research to very large organizations, both in the private and public sector, such as Boeing, Lockheed Martin, and NASA. We actively work with certification organizations such as FAA and ASTM, and we've literally written the rules on materials testing for organizations like FAA. So today what we're talking about is leveraging this growing and diverse student body that has become internationally recognized into opportunities and services, not only for applied learning, but additional ASTM testing into the plastics industry, which is, as we say here on this slide, we're now proud to be part of the IAPD membership. So first, a little bit about Wichita. If you've not been, we're known for our aviation heritage. As you can see on this slide, in the lower left-hand or on the left-hand side is a picture of one of the very first Cessna aircraft. It was an innovative wing design that didn't require struts. And I'm not sure exactly what year that photo was taken, but it's circa 1920s, I believe. Since that time, here in Wichita, we've been a part of virtually every innovative aviation program, from turboprops, the King Air, to military, airborne laser platforms, Air Force One, and both commercial and private jet activities, as shown here by the United Airlines and Cessna Citation 10, which is the world's fastest business jet built here in Wichita. A fun fact, today, if you look at every airplane flying in the commercial fleet around the world, 26,000 of those were built here in Wichita, primarily at the Boeing facility. In the past, every 10 to 12 years, there's been a major up and down cycle in the aerospace industry. Currently, we're in the 17th consecutive year of an upswing. And as we show here in the lower left, that's because annual or global air traffic is growing at about 7% per year. Obviously, a lot of plastic parts in these aircraft. Spirit Aerosystems was spun out of Boeing, I think about 15 years ago. It's based here in Wichita now, and they have a huge presence here on our campus with over 1,000 jobs and over $1 billion in investment in the next 5 years. So that's just a little bit about Wichita and our aviation heritage. let's now turn specifically to the labs here at Wichita State University that hopefully of our interest and relevant to this topic here this morning. So let's start. I'll just rattle a few of these off, the ones that I think would be of most interest to the plastics industry. Additive manufacturing, that's a big growing area of interest across a variety of industries. We've really kind of set the bar in that topic, and we do a lot in robotics, 3D printing, and a variety of other areas that are helping industry take advantage, of additive manufacturing, advanced coatings, composites. Let's see, environmental testing there in the middle. We're going to talk a lot about mechanical testing today, reverse engineering. We've got an enormous effort going with virtual engineering and virtual reality that we'll talk a little bit more about. So just a quick summary of all of the breadth and depth, I should say, of all the laboratory expertise we have on campus here at Wichita State. As it relates specifically to plastic testing and research, today we're pleased to offer a wide range of ASTM testing. This slide talks about compression, ASTM 6641, 695, and 3410. A couple of pictures of some of the testing equipment that we use on a daily basis there. Tension testing is a really big part of our activity. I was told that we order, and Shin, keep me honest here on the terminology, but we are the top purchaser of string gauges in the country. Do you have anything you want to add to that? Nope, that kind of summarizes just how much we're doing in the area of tension. String gauges would be used in tension, right? Yeah. So pretty big effort here on campus in that area. Shear testing, another common test that's relevant to the plastics industry. ASTM D1002, 2344, 3518, and then Notch 5379. A couple of our several images here to illustrate what we're doing in that area. So in summary, a very dynamic, very deep, rich capabilities across chemical, physical, and mechanical testing that we're proud to now be offering to the IAPD membership. Some other images there. Also, if any of you are interested in environmental testing and electromagnetic effect testing, lots of activity and lots of capabilities across those topics as well, and some images here that show some of the activity in that space. So now let's talk a little bit about research. Obviously, as an academic institution, we pride ourselves in our ability to assist industry with research projects. I wanted to talk a little bit about some of the FAA research programs that are active, but kind of bleed over into the plastics polymer areas as well. Thermoplastic unidirectional material. I'm not 100% certain what that means. A lot of big words here I'm not even trying to pronounce. That I'm gonna try. But you can see here it's an area of expertise for us. Adhesive bonding and paste. You can see some of the companies that we've done work for in that area. polymer additive materials using Ultim 9085, fiber reinforced repair materials, and ceramic matrix composites. I'll pause there. Just, are there any questions on those research programs? I'll take silence as a no, but just jump in if anyone has any questions on that. So lots of stuff going on in materials testing, and this next slide really illustrates or makes an additional point on that. We were a founding member of NCAMP, the National Center for Advanced Materials Performance. The pictures here illustrate, I think those are F-22s. Do you know, Shin? F-35s. Okay, both an F-35 and an F-22. Obviously, some advanced materials needed to make those aircraft perform the missions that are required by the Air Force and NASA. And I guess the summation there, we're focused on increasing the efficiency of these advanced materials that are used in these aircraft models while decreasing the cost at the same time. That led us to, on this next slide, that led us to become the first university strategic partner to ASTM. This is just a snapshot of that news release. This happened late last year, if I remember the dates correctly. And the headline here is the National Institute for Aviation Research, which is here on our campus, joins ASTM International Additive Manufacturing Center of Excellence as the first strategic partner. So I thought that would be useful information to this audience this morning as it relates to what we're doing and what we're trying to build into around ASTM. Lastly, I want to talk about, I think, an important topic for your industry, and that's producing qualified students with a rich understanding of what's going on in your industry. Something that you may not know about, we've created an innovation campus, and it's really becoming an internationally recognized model of how you bring industry onto your campus. You see a picture here of an Airbus facility. Shin, I don't know how many Airbus engineers are there, but a lot. Yeah, the U.S. Airbus U.S. headquarters are now physically located here on our campus. And why that's important is it allows students to work directly with industry and gain firsthand knowledge. We call it applied learning experience. And the vision there, as I've already mentioned, is to really bring this applied learning model, make it a reality, and help us become, it'll become something essential to educational, culture, and economic driver, not just for Kansas, but for other regions. And on this next slide, there's going to be a short video that shows what Dassault Falcon has done here on campus. So I'm going to let that play and then keep talking when it comes on. There's no sound, so don't think your video's not, or your audio's not working. So you can see a bird's eye view of the campus, some of our 3D robotics labs. So just a short video there. I thought you all, the audience, would like to see that, just a bird's eye view of the campus. And as the text says here, what we're doing is, supporting early stage activities, early stage businesses, and most importantly, growing a workforce that can transform industry strategy into, real life businesses and new verticals, new new concepts. And the real takeaway here, and this is the last slide, what we're doing is, what you see here is the estimated time in months over on the left, the first bar. This is a traditional education without co-op. The literature says it can take as long as 2 years in the current economic climate for a newly graduated student to become effective. With co-op, the second bar, that can be shaved down to about 18 months. But the third bar, with our innovation campus and applied learning, we're seeing the time really shrink to less than a year for a new student to become truly effective and start adding value to companies. So we think it's a different model that produces graduates with not only relative experience, but the ability to come out and make a very quick impact on your business. So that concludes the presentation. Like I said, we're thrilled to be a new member of IAPD. This is my email address, and we will have a booth at the upcoming convention in September in Miami. So I hope that was useful information. Courtney, I'll turn it back over to you.
Thanks, Alan. As a reminder, please submit any questions using your webinar toolbar. As we wait for questions to come in, I'll take this time to remind you that in a couple weeks, on Friday, September 13th, our next webinar will be going over the introduction to the IAPD thermoplastics rectangle. So make sure to register for that. We'll give it one more minute in case people are typing in questions. If after this presentation you think of a question, please feel free to email IAPD or Alan directly at the email address on the screen. We will go ahead and conclude our presentation. As a reminder, you will receive a survey about today's presentation. Once you complete the survey, there will be a link to download the presentation slides. A recording of today's webinar will also be available on the IAPD website on the webinar page. Have a wonderful Friday. Thank you.